Okay, so this is our first time graphing using the parent multiplier and shift method. Okay, so for this, we're going to start off with our parent function, okay, that we studied in our basic skills for ln x. Okay, and so just like other parent multiplier shift that we've done, we want to get the parent function on here, so it's going to look like this. Okay, and the three kind of points that we want to start off with are going to be always start the same for ln x, and so we have 1, 0, okay, and then 2.71 and 7.42, and we got those numbers from this part right here. Okay, so we want usually use these three that are going to help us put the first part of the graph on there, give us a nice, firm base of points to move around, multiply, and all that other good stuff. Okay, so let's take a look at how we're going to actually, you know what? One last thing, or one thing that before we start, I do want to mention that we also have an asymptote here. Okay, which is going to be at x equals 0. Okay, and to show you the inverse relationship of that, like in the this video or this exercise that we just did, is that if I went ahead and had, we know that exponentials have a horizontal asymptote, okay, at y equals 0, and so it would make sense that our logarithmic inverses are going to have an asymptote at x equals 0. Okay, so we want to put that down there first because we're going to be shifting that around just like we shifted around the exponential stuff. Okay, so let's start putting the pieces together. Okay, so the number that we have in front kind of playing the same tune as the every other parent multiplier shift is going to be this guy right here. And we don't want to use exponentials to put it back up there or anything like that. We just want to call it as it is. Okay, so the multiplier, okay, that means is that we're going to multiply our y's by 3. Okay, so that's going to pop up each one of these 3 spaces. Okay, so this is y is 0, so 0 times 3 is just going to stay put. The next one, this is going to pop up to a 3 right here, and this is at 2, so it's going to pop up right here. And this is going to give us our new graph that's going to look like this coming through here. Let me do it in a different color. I don't like that. But anyhow, the multiplier does not move the asymptote or anything of that sort around. Okay, so it's going to stay put until we do the shift. Okay, so the shift is going to be these guys right here. Okay, and we know that inside of a function we go opposite that many, and I don't know if I said inside or outside. Inside the function we go opposite that many, and outside the function we go in the true direction that many. Okay, so we don't do the opposite at all. So our final build of the function is going to be this guy when we put everything together, and we know that we're going to be going opposite of a positive 2, so we're going to be going left 2 and then up 1. Okay, so one of the things that we want to do is that when we shift around the graph, we want to shift around the asymptote as well, and I usually start there. So I know that I'm going to be shifting left 2, so I want to make the asymptote shift over 2, and that's going to give me a new equation at x equals a negative 2 coming down here. Okay, so the whole thing is shifting on over, and I'm going to get rid of the old asymptote. And now each one of the blue points are going to go left 2 and up 1. So I go left 2 and up 1, and I go right here. And let me use a different color. Left 2, up 1. So left 2 up 1. And we're doing, oops, I did the wrong one, so sorry about that. Left 2 up 1. And left 2 and up 1. All right. And so this is going to be our final graph right here, okay? And that's going to be good enough to get us where we need to go. So I'm going to, at this point, take a look at the x and y intercepts, and we might need a calculator to knock those things out. So let's see how accurate we are, and I'm going to get rid of the this part as well, so we can isolate our graph and label it up. And yeah, let's start with the x-intercept. Okay, do out the x-intercept, okay, and we're going to have more practice with this later, so if you don't get it right away, that's okay. Then you can always go back and fill these in later. So we got 0, okay, so we're letting y equal 0, and we have 3 ln x plus 2 plus 1, okay? So the first thing that we want to do is that we want to get the ln stuff by itself so we could use the definition. So I want to subtract 1 from each side, and that is going to give me a negative 1, and bring everything down. And then I'm going to divide out that 3 that's in front, okay? And that's going to go out. And I end up with, I'm going to bring it around here, I end up with a negative 1/3 equals ln x plus 2. Okay, so what we're going to do is that we're going to use the definition that we practiced before, but we're going to definitely need help from a graphing calculator here, or just a calculator. So this is the base of e. So our definition, I'm going to go e to the 1/3 power equals everything that's in here, which is going to be an x plus 2. So I will go x plus 2 equals e to the negative 1/3 power. And then I want to subtract that 2 off so I can get the x all by itself, and I get x equals e to the negative 1/3 power minus 2. So that's the exact answer of what the x-intercept is. However, we don't know really what the numerical value is off the top of our head, so what we're going to do is throw that into a calculator and see how close our graph is. All right, after consulting my calculator, I get that this value is going to go ahead and be estimated out at a negative 1 point, and I'm just going to take it 2 decimal places, 28. That seems pretty good, because if you look right here, that x value looks about a negative 1.2, 1.3, something, negative 1.3, something like that, okay? So I think we did pretty good with that. And so I'm going to be rolling with that, all right? And so, and really all of them that we're going to be practicing at the end of this video are going to work out the exact same, are going to have the same algorithm for the x-intercepts. So if you just follow this example, it'll get you where you need to go. For the y-intercept, we know that we're just going to be plugging in the 0 for x, okay, because we always plug in 0 for the opposite value of what we want, okay. So at this point, I'm just going to throw this into my calculator and see what shakes loose from there and see how close we are on our graph. All right, and the calculator says is that that's about 3.08, and that's we did pretty good there too. If you look, there is y equals 3.08, so we were pretty darn close. So we did a good job graphing. All right, and so the last part filling out, oops, that's a weird looking 0, is going to be the asymptote, and the asymptote for logarithmic functions is always going to be an x, because x equals a constant is going to give you a vertical line, so it's x equals a negative 2. Okay, so that's how you do that. And I you guys are going to get some practice problems, about 4, maybe 6 of these, to go ahead and knock out and practice, and then check your solutions, and we'll get some we'll get some questions and answers from there. So that's how you do that, and I'll see you in the next video.